So welcome to another Feature Friday, and today I'm delighted to be joined by Romain again. So Romain, do you want to introduce yourself?
Yes, hi. My name is Romain Decker, and I'm a staff technical product manager in the CSBU, so Cloud Services Business Unit, and I cover everything networking for our cloud providers there.
Yeah, you are the networking guru, so thank you again for joining us. And my name is Guy Bartram. I'm the product marketing cloud director for Cloud Director. There's too many uses of the word director there, but here we go. And today we're going to be talking about some of the new NSX-T features, particularly focusing in the northbound routing and external interfaces, the options for external networking. We'll touch on some of the new VRF-lite functionality, right, Romain?
Yeah, exactly.
Okay, cool.
So where should I start? I will start without slides first. Just want to do a bit of history before going deeper in the demo. So VCD has always been associated with NSX. So with NSX-V, you had multiple options to connect external networks. So external networks represents basically what's outside VCD. It can be internet, it can be MPLS, it can be a shared service network like backup, monitoring, and so on. And historically, with NSX-V, you had multiple options to connect an external network, and those were essentially based on distributed port group. Now with NSX-T coming in, we shifted the way it's designed and working, and now we have this notion of T0 gateways and VRF gateways that have to be imported, and that represents logically the external network. And we have multiple options on how to design them, and if they are shared or dedicated, if you're using a T0, when to use a VRF, and so on. So we shifted from basically just using a regular distributed port group to a more logical object, which is a router in NSX-T. And I will explain why.
Okay. And this is obviously something that's fairly well covered, if not covered completely, with the NSX migration tool, right, from B to T.
Yes.
Yeah.
So a quick recap first. So we have this concept of external network, which is a provider construct. The external networks with NSX-T can be T0 or VRF gateways. They have to be created upfront in NSX-T and then imported into VCD. So VCD just consumed them. It also touched them by changing route tables, forwarding tables, and so on. But basically, it consumes them. It doesn't create or delete them. The edge gateways are translated into tier 1 gateways in NSX-T. And the big difference is that in NSX-T, we have this 2-layer approach where a T1 gateway, so an edge gateway, can be connected only to one T0, so only to one external network. In the past, with NSX-V, basically the edge gateway was a VM appliance, VSE or an ESG, depending on which name you use. And you could connect up to 10 physical NICs to that virtual appliance, meaning that you could connect 10 different external networks. Here it's different because the edge gateway is now a logical construct, which is running in the NSX-T edge nodes and can only be associated to one external network.
And the edge gateways, once you've created your T0s and VRFs and imported those into VCD, your edge gateways, and then something that you create in VCD, right?
Yes, exactly. They can be created by a system administrator only, and they are associated always with an external network. The org VDC network are basically NSX-T segments, overlay segments, and they are based on an overlay transport zone backed by Geneve. So in NSX-T, we are using the Geneve protocol as encapsulation compared to VXLAN before with for NSX-V.
So Romain, how would we then in NSX-V, where you could attach up to 10 external networks to your ESG, now I've got limitation. I've got my tier 1 gateway. I can only attach one single network to it, which is attached to a T0 or a VRF gateway. There would be multiple links on the T0 though, right?
Yes, and it's again, as we have shifted from this previous model now to this new NSX-T model, we have to pay attention on which term we are using. So we don't connect networks technically. So the network siders, so the range and the subnets that you assigned to external networks in NSX-V, those were actually living on the external uplink. So those IPs were living and answering to ARP requests directly on those external networks. In NSX-T, although I have connected it to the same WAN and internet, the decider that they have to be routed up to the T0 and VRF gateway. It's the big difference. So those are networks that we route up to the T0 and the VRF gateways. And the allocated network in the external networks, the allocated siders, those are not IP living on the physical uplink of the T0 and the gateways.
So essentially you're having a default route on a T1, which says that anything that isn't these internal org VDC networks is going to go up to a T0. And then
Yes.
on T0, you're capturing all of the routing, whether it's in a VRF or however it's connected.
Yeah. So the external sider is actually something that is routed from the physical world up, and they have to be routed to the T0. So it's not IP that are living. And if you're not consuming, if you're allocating IP from those external networks to an edge gateway, but if you're not consuming those, the IP won't even answer to ARP requests or to ping requests because they will not be advertised externally. So it's basically, we shifted from a model where it was going out, so in NSX-V, going out of the edge, it was just ARP and L2.
Yep.
And in NSX-T, here it's basically layer 3.
Yeah, so this is the whole different way of thinking about it.
Yeah. And if someone is familiar with the way how NSX-T is integrated with Kubernetes, for example, it's exactly the same concept. So with Kubernetes, either using Tanzu or Enterprise PKS, or the old name for TKGI, and so on, they have a concept of a floating IP pool, as they name it. And this is a pool of IP that is supposed to be routed up to the T0. And those are not IPs that are supposedly living on the interface of the T0. But I will explain with a demo. It will be more easier.
Yeah, I think I've got it.
And so we are now in VCD 10.2 since, well, actually it's 10.2.1 since January, and before it was 10.2.0. And if I remember correctly, in VCD 10.0, we introduced the fact to import an NSX-T T0 in a shared mode to connect edge gateways, meaning that you can have a single T0 here that connects to internet or to a different network, and that is shared amongst multiple edge gateways coming from the same tenant or different tenant. Mm-hmm. The main consideration is that you can only access the workloads, so in and out, using NAT, so network address translation. That's the only consideration. But it's not negative. It's just a way of thinking it, because you can NAT allows you to have overlapping IPs between tenants and different subnets. So you don't really care if the different organizations create organization VDC networks with the same IP ranges.
Yep.
So you internally of the org VDC, you can create networks. They can have overlapping IP ranges. And if you need to have egress access, so if you have to access internet, for example, you do a source NAT using one IP or multiple IPs. And if you want to access, I don't know, a web server, you do a destination NAT. So that concept of a shared T0 was introduced in 10.0. And then in 10.1, we introduced the fact to have a dedicated T0. And the main consideration is for a dedicated T0, it's not dedicated to a tenant, it's dedicated to a particular edge. Because you always have that one-to-one relationship between a T0 and a T1, but an edge gateway can only be connected to one T0 or to one VRF. So using a dedicated T0, you can now access directly using layer 3, so routing, to your org VDC networks. You don't have to use NAT.
Yeah.
And that's useful if you want to access one like MPLS or co-located networks, or if you have physical workloads that are hosted in the rack next to your workloads or in the same data centers and so on, if you just want to access them without using NAT. The caveat with that was that you had to dedicate a complete T0 to an edge gateway. And that introduced a scale issue, because a single NSX edge node can have a maximum of one T0 running in it. And we have a maximum of 320 edge node in NSX-T, if I remember correctly. So you had a max number of possible T0 that you could dedicate. And also adding more and more T0 consumes resources.
Yeah. What about active-active in that respect? It's two, right?
Active-active in which sense?
In this fully dedicated sense, so there would be two T0s in active-active scenario.
So the T0, it's a logical construct. It's actually running in an edge node, in an NSX edge node.
So two edge nodes then?
Yes. So in NSX-T, you have the NSX-T fabric is composed of multiple components. So one is the hypervisor transport nodes, one is bare metal transport nodes, and then you have NSX edge nodes, which are basically just a component to run centralized services, which is called SR, Services Router in NSX-T. And you create NSX edge clusters that can have a maximum of 10 edges. And when you create a T0, you assign a T0 to a specific edge cluster. And the T0 is created either in active-active or in active-passive. If it's created in active-active, we use ECMP to go out, so equal cost multipath. So we can go up to 8 edges in active-active. If it's active-passive, it's only 2, and one one edge will run the active component of the T0 and one edge will run the passive component of the T0. However, for external networks, usually it's recommended to go more with active-active because we don't really care if it's active-passive here.
Yeah,
so
in that shared environment, you'd definitely be running active-active as well, right? Usually.
Yes, yes. So we had this scale consideration, and that's why, so you had to create multiple edge clusters to run many T0s. And in VCD 10.2, we introduced a different concept. So NSX-T was already supporting a VRF, so virtual routing and forwarding, which is a standard even with other vendors. And it's the way of splitting and having isolation between route and forwarding table inside the same routing component. So we have now introduced in 10.2 the support in VCD to import a VRF as an external network. The big benefit is that one T0, one parent T0 can run up to 100 VRF instances. So we are basically multiplying by 100 the maximum scale of the infrastructure. So now you can dedicate an edge gateway to a VRF. And that VRF is actually living in a parent T0 that you are not using. It's just living there, just for the purpose of running the VRF. And one small detail, you cannot have both the child VRF imported as an external network and the parent T0 imported as an external network at the same time. It's either one or the other.
Yeah.
So in the case when you are using VRF in external networks, the parent T0 is just living there just for the purpose of the VRF.
Yeah. And in this case, so you got VRF-A, VRF-B on a shared T0. So
yes.
this T0 essentially is just running the VRF function. Is not anything to do with one particular tenant, is managing the VRFs for both of them.
Yes. And I only have one edge cluster, which is here, with one edge node and the second edge node. That's it.
So essentially, we've solved the scalability problem. That's what VRF does. Okay. And sorry, go
on. The main difference is how you access now how you map your internal networks to the external networks. And so if you dedicate an external network to an edge gateway, you can either route end-to-end up to a collocated network or an MPLS, or NAT at the same time. And by default, it's NATed. And the only thing is that if you want to have at the same time access to, I don't know, MPLS and internet, basically everything will be NATed by default to internet. And you just say that particular networks will have a no SNAT rule to MPLS, so to the MPLS network.
So in this scenario, then the provider is providing an internet service as well as an MPLS, or participating in an MPLS network.
Yes.
In the scenario where the customer has their own dedicated MPLS and one of the MPLS endpoints is a hub and spoke to the internet, then what you would have, you wouldn't be using that at all, in that everything would be going out the MPLS route with VRF.
Yeah, well, it depends. It's just up to the providers and to the tenants to decide if they want to go out using the MPLS and then internet through the MPLS. But usually in the situation, they are not connected at the same time to a shared internet connection provided by the service provider.
Yeah. Okay.
So in other words, if what I just explained, if, for example, if I have a 1.1.1.0/24 network as the MPLS, I just want that network to have no SNAT. So that no SNAT is just defined in the edge gateway. So by default, when a virtual machine will access, will just try to go out, it will be by default, it will be NATed to internet, except if the VMs belong to that particular network and they want to access the MPLS network, then the edge gateway will cancel the NAT with the no SNAT rule.
Yeah. Okay, so the point to remember here then is if you're going to be connecting to an internet gateway as an external network on your T0, then you're going to be using that. Anything else is going to go through VRF.
Yes.
Okay.
Or dedicated T0.
Yeah, or dedicated, yeah.
I can see still some situation where some customers, some tenants would want to have a dedicated T0 instead of a dedicated VRF, potentially for bandwidth, if they are heavy bandwidth consumers. Because obviously, if you have a parent T0 that is composed of only 2 or up to 8 edge nodes, well, the bandwidth is shared between all the tenants. That said, it's not that bad because you can go up to, I don't remember if it's 40 or 50 gigs per second per edge node. So you have plenty of space
And
to
if you're running
have
active,
some bandwidth.
yeah, if you're running active, do you then get to share that, or is that still singular?
No, it's shared also.
Oh, that's cool. So yeah, that should be enough.
So enough with the slides. Just show you in VCD what it looks like. So I have a VCD, I think it's 10:1. Yes, it's 10:1. So I imported a few external networks. So as you can see, the last 3 of them are NSX-V external networks. They are distributed port group. So when you create an external network, if you want to say it's an NSX-T resource, you just select the NSX-T manager that is already connected into VCD. You just give a name.
So those resources you have to configure in NSX first, right, for them to be available
Yes.
for it. Yeah, yeah.
You have to create the T0 gateways and the VRF gateways first here to configure them, create the uplinks to the transit networks, and even create peering if you want to your internet routers and so on. And then you can just import them. So the step here is just to import. So you can import a specific T0 into the VCD. And you can see that VRF gateways have just a check mark.
Yeah. Yep.
Technically speaking, VCD doesn't care much if it's a VRF or if it's a T0. It just wants it to be configured before and import it. So VCD, this checkmark is just for information. VCD doesn't really care. And then in configuration, that's the CIDR that I mentioned. So that CIDR is supposed to be a range that is routed up to the T0. So it's not something that is connected directly to the T0. It can, but you're losing some capability if you're just connecting, if you're just putting IPs of the transit uplink here. But here it's supposed to be a range that is routed up to the T0 or up to the VRF gateway.
Why would you need a range for that? I mean, you always have a range, but how big a range are you talking about? I mean, it needs to be the broadcast two ends and the actual network
No,
addresses.
it depends. It depends on how many edges you will connect and how many NAT addresses you want.
Oh, I see. So this is okay. So this
So
is for the
this will be consumed by NAT in the edge gateways.
got it. Right. So this is
If you do,
T0 configuration.
yes. So those are not technically living on the T0, these IPs.
I see what you're saying. Yeah,
But
okay.
I will show you. It will be more clear, hopefully. So I already imported a shared one that I'm using. So I have, for example, in this one, I have defined two networks. So this one is actually living on the transit network. So just externally to the T0. And this one is routed up to the T0. And the IP pools are the IPs that I can consume and assigned to gateways. So I have gateways that are already consuming some IPs. So for example, Moonbeam Edge 1 consumes IP 167 and then 180 to 189.
Yeah.
So now if I open, for example, my Moonbeam organization, I have one org VDC. I have one VApp, which is Feature Friday, that has 3 VMs, 3 web VMs. And then I have a fourth VMs that is Data01. And I have two networks. One is connected to Edge 1, and the other one, which is 192.168.52, is connected to Edge 2. So for the moment, Edge 1 and Edge 2 are both not dedicated. So if I come here, if I edit the Edge 1, yeah, I don't know why that's happening. Okay. So this one is not using a dedicated network. The other one, neither. So for the moment, to access my web servers, I need to have a NAT rule. So my web servers are on the 51 network. So if I want to access them, I have to create a destination NAT rule. So I have created a destination NAT for Web01, where I'm taking an external IP from the external network, and I map it to an internal IP. And then I do the same for Web2 and Web3. But sometimes, and most of the providers actually want to provide routed networks. So NAT is fine to access a front-end server or web server and so on. But if you have to configure NAT rules for all ports, for all your applications, it can be time-consuming. So sometimes you want to access from a private network, so a colo network or an MPLS or a WAN that you have that you bring into the provider data center. You want to access directly your workloads. You can do that by dedicating an edge network. So for example, the Edge 02, I connected this to, you don't see it, but to the VRF, but I have not enabled using dedicated external networks. You can dedicate an external network in day 2. You don't have to do it in day 1. So that's a very good thing. So if I now dedicate the external network, it means that I'm dedicating the external network, and you will see that at the top, at the left, bottom left, you have a new section that appears. It's routing. This routing piece is actually a representation of the routing configuration of the T0, because you're dedicating that T0 or that VRF to that edge gateway, you can expose the routing configuration of the T0 to that edge gateway because it will not conflict with other edge gateways or with different tenants. And what it allows me to do now is to configure actually BGP. In my situation, in my lab here, I cannot edit that piece because VRF inherits from the parent T0 BGP configuration. So you do the BGP configuration, so the local IS number, graceful restart, and so on the parent T0. But what I can do is configure neighbors. So I can create neighbors. I think it's this one. The remote AS is 6501. And then I just want to do IPv4. I will create a new one. It's my second external router.
And then you're going to let the eBGP take care of the propagation of these?
So for the moment, I just established so before the recording, I configured the BGP on those two external physical routers.
Right.
And by configuring this, I just established the BGP peering with the physical routers. So that's my router. So if I do a show BGP sessions, I can see that I have two neighbors. So those two IP correspond to the two edge nodes where the VRF is living. And the ASN is the one that is configured here.
Yep. Yep.
But I'm not learning any routes for the moment. So I just have the default route that is propagated, but I'm not learning any route. To propagate routes, now I can specifically advertise subnets or IPs.
Yep.
So I want, in my case, to advertise my 52 subnet. And that's it. So now from the external world, when I access my T0 or my VRF, I can do an end-to-end layer 3 or end-to-end routing up to the workloads running in my ORVDC and connected to my ORVDC networks. So now I can see that I am learning that route. So the little E is for ECMP, and I'm learning that particular network from those two edge nodes.
Yeah, perfect. Okay, yeah, that makes sense.
Yes. So I can have it, and from the same here, I can also say that for a specific other network, I don't want to use routing, and I want to just connect to internet using NAT.
Mm-hmm. Romain, how much of this can be done, because there's certain things that can't be done in VCD here, and certain things that can be done in NSX. How much of this is also reliant on you getting the NSX edge cluster configuration correct? Just trying to work out when you're doing your edge cluster configuration, there's obviously a lot to think about here.
Mm-hmm.
And you're going to want to perhaps go back and change it later if you missed something. Is that doable? Is it flexible like that, or is it? I mean, once you start configuring, I mean, you're going to be in it.
There are things that are flexible enough and really flexible in NSX-T. You can, for example, switch. I don't know, this T1 by default. The T1, the edge gateways are running on the same edge cluster, NSX edge cluster as the external network. Mm-hmm. But that can be changed on the fly. You can just select a different NSX-T edge network. and that can just be in day two, like on the fly. For external network, it's a different story. It's a bit more complex. Remember so we have multiple layers of abstraction here. The NSX edge cluster is just a logical construct that contains multiple edge nodes. Mm-hmm. The NSX edge nodes are empty components that will run one T0 and potentially multiple T1. Once you have created a T0, you can change the edge cluster where it's running. So that's quite quite powerful because you can change it. But you cannot change. I think I remember if you cannot change is go from active standby to active active. The opposite is true, but not this nonsense. What you cannot change is in VCD, for example, an edge gateway. You cannot reassociate an edge gateway with a different edge, with a different external network. Okay. And also, when you start using VRF, there is some work to do in NSX-T before offering the dedicated external network or the VRF as a dedicated external network to a tenant. You have some work to do. Obviously, you have the T0, the parent to be created. So that's this one for me. And then each VRF, you have to create a new VRF gateway where you select the parent T0. So that was easy, but then you have to create interfaces. And here is where you have to provide IPs to do the peering between the VRF and external physical routers.
Yeah, yeah.
This can be automated using Terraform, though, when Ansible, using the NSX-T Terraform provider, not the VCD Terraform provider.
I mean, it's no harder than the old days of having to configure clock rates and things like that and CLI. It's just you got to get stuff right, haven't you? That's the challenge. Yeah, I think it's easy if you've got shared gateways, no doubt. Shared is better in this respect.
Well, it's less work.
Yeah,
it's not easier. It's just less steps.
Yeah,
but using dedicated or VRF as dedicated, it's not much more difficult. It's just a different concept. So you have to do a few additional steps.
Where do you see most providers doing this? Is it going to be more of a shared instance for, I guess it's going to be down to the customer requirements, and
yes,
they've got their own MPLS networks, and that's obviously a very specialist thing, full stop. And it's going to require some specialist configuration in NSX-T to interface to that, and then to do the route propagation down T0s.
Yes.
T1, sorry, yeah.
Most of the providers we have been speaking with are interested into having dedicated VRF to the edges. And on those dedicated VRF, they want to provide at the same time access to an MPLS, to a private network of some sort, and internet at the same time.
So they wouldn't be using that, then they'll just be using the VRF for an internet hop, which would be local to them in any case, not necessarily out through the customer's MPLS network.
Yes.
Yeah, I guess it makes it easier, I think, if you do all or nothing type approach. If you have every customer connected to a VRF and you decide that's the way you're going to do things, do you then run into any scalability challenges?
In which situation?
Because you can have a VRF per edge gateway, right?
Yes.
But only how many VRFs can you run on edge gateway again? So I'm trying to.
You can have up to 100 VRF per T0.
Okay, so if you decide to do everything in a VRF world and you decide to do active-active, then you're probably going to do 100 or slightly less than that.
Yeah, maximums are good numbers to know, but usually I wouldn't recommend to try to target a maximum.
Okay.
Even if it's tested. So you can take a conservative approach and try to define like some blocks or some pods, and you can just say, I will have, I don't know, 50 VRFs on that T0, and then I know I have to create a different T0, and I will have 50 VRFs on that one, and so on.
Yeah. Yeah, that's what I was trying to get to. So good to know about the config maximums. Point to note to anyone who's watching. But I think, yeah, if you have that level of kind of continuity, then it's going to make things a lot easier, isn't it, to set the rules up straight away.
Yeah. Yes. And you mentioned multiple times active-active or active-passive. Really, in that situation, it's not really important. So T1, so edge gateways, will always be created by VCD. So they will always be created in active-passive. T0, as they have to be created by the provider, by the system administrator, usually we recommend for them to be active-active, except if you have a specific situation where you need to have active-passive. Those specific situations can just be if you want to do proxy ARP on the uplink networks, or if you want to run at the same time a centralized service outside VCD, but at the T0 level.
Why are T1, sorry, active-passive by default?
So it's not by default. It's VCD that creates them active-passive, because you need them active-passive if you want a service router in the T1. And the service router is required if you have centralized services such as NAT or firewall, DHCP, DNS, and so on.
Okay, that makes sense.
Because we know that the actual, the big reason on why we want to provide edge gateways to the tenants in a self-service is to provide additional services, such as NAT firewall and so on. So we need to have them in active-passive.
Okay. Very good. Well, I think this opens up a whole load of interesting opportunities and certainly works around a big scalability concern that we had before. So this is really good to see. Is there anything else to show before we wrap up?
There was one thing that I wanted to show is just to mention a second time. When we do edge, the network that I'm using, so that edge gateway is connected to a shared T0, so providing a native access to internet, so source NAT, DNAT. So I'm consuming those IP from the network specification. And the way it's doing it, the IP are not advertised by the T0 until they are consumed by something. So until I'm consuming edge gateway, so nothing was advertised until I created the NAT rules. And the way it's done in NSX-T is, so if you remember correctly, it's this one. Just check. Yes, it's this one. Would be H1. So there is a route redistribution configured automatically by VCD. that is static route, and then there is at the T1 level. If we take this one, route advertisement, there is a route advertisement rules configured here, named System VCD Edge Services, that connect the NAT IPs. So
that's done
everything
on when the NATs are created.
Yes.
Actually created, right?
Yes.
That makes sense. No need to advertise something that isn't being used.
No, as soon as you create a NAT, so how can I let me try to think. If I create here a NAT on an IP, I don't know, 189, for example, NAT feature Friday, the external IP, I will just take 67.29.29, and then internal IP. I will not save it first. I hope this works. 69.29.199. So that's not working for now, but it should. I hope my lab is in a good shape.
It's going to be a test.
It's not. It's not in a good shape.
Well, I expect to take a few minutes to pick it up.
No, it's supposed to be quite. But basically, you it's not working. But you get the point. It's
yeah.
The route is not advertised, but I have nothing in there. I don't know, maybe behind this one. And yeah, that's the demo effect.
Don't worry, it's clear to me that it's got to be created, and like you say, something does something actually have to be attached and consuming it?
Yeah.
Okay.
But my VMs may not be all up and running. So, but basically, this would be the last step that you do after creating your workload, deploying the NAT, and then the IP will be automatically advertised from the T1 as a NAT IP to the T0, and the T0 automatically to the external world.
Yeah, sure, understood. Excellent. All right. Well, that's really good content there, Romain. It's a whole new way of kind of trying to think about the routing. It's definitely a slight change from the traditional way we've done things, and it's really interesting to see the implementation. I think there's a lot of from looking at what I've seen today, there's a lot of consideration I think that should be done up front in terms of the external connections and how you want to configure your edge NSX clusters. And then obviously that translates into sort of the more dynamic stuff that we've just seen down in VCD, which is not a problem to do on the fly, which is great. And like you say, it's going to offer options for service providers to do much more complicated stuff, and to connect to those customers that have MPLS, or if they're a provider offering MPLS, to connect it through nice and easily.
Yeah.
So Romain, thank you very much as always. Really appreciate your time, and thank you for showing us around the VRF-lite and NAT functionality of NSX-T. Really appreciate your time. Cheers.
Sure, anytime. Cheers.